Well, we can track asteroids by observing them with a large space-based or a ground-based telescope. Normally we do this from the ground. So just envisage yourself using a large telescope with a digital camera, and what you will see in the images are many stars, and the asteroid typically then is moving across these stars. Now we know the position of the stars very accurately, and by measuring the position of the asteroid relative to the stars, we can find out where the asteroid is in our solar system. We do this not just once, we do this, say, a number per night or several times per month, sometimes even several times per year, and that gives us very precisely the position of the object in the solar system. The question is, can amateur astronomers help observing asteroids? And the clear answer is yes. Not only can they actually do help. A very large number of what we call follow-up observations of asteroids is actually done by amateur astronomers. So they are really an important help in this topic of observing asteroids.
Asteroids are the remnants of solar system formation, of planet formation, so they are kind of the leftover of those building blocks who have formed the planets. They were just close to Jupiter, and therefore they couldn't completely evolve to full planets. They are made of either rock or dust or metal or a mixture of those, and they have probably formed from a number of larger bodies, that were destroyed through collisions. And so originally they were all about the size of what's now the largest asteroids, and due to continuous collisions we have now many, many smaller ones as well. Asteroids are moving around the sun, so it's the gravity of the sun that keeps them moving in the same way that the Earth moves around the sun. Indeed, if asteroids get close to a planet, they may be ejected from their orbit, get into different orbits, and some of those asteroids are the ones that get into near-Earth space and then at some point may become a danger for Earth. But many of today's asteroids are in so-called resonances, which are orbits around the sun that have the property that they never get close to any of the planets, or mostly Jupiter, which is the main threat in that sense for asteroids.
In general terms, the impact probability goes with the size of the asteroid. Large asteroids, we know today, are most likely not going to hit the Earth before 1 million years or so. However, the threat lies in the smaller asteroids, which have a much higher impact probability with the Earth and more frequent. Recently, the last event in Chelyabinsk was an asteroid of 15 meters size, and this happens with a frequency of about once every 100 years. We've been studying asteroid deflection techniques since over 10 years at the European Space Agency, and we know now that the likely threat will be coming from a small asteroids, for which the kinetic impactor is the technique that should be really used. So we now plan for a mission to test this concept, the Asteroid Impact Mission, which is due for launch in October-November 2020. And we hopefully get the funding to do this test in orbit.